Have you ever wondered what the final day of our planet will actually look like? What happens to the cosmos when the very engines of creation run out of fuel and go dark? How does a universe, born in a blinding flash of light, finally come to its terrifying, absolute end? Welcome to Silence of Space. We tell the universe. For 4.5 billion years, our Sun has been the faithful guardian of our solar system. It is a main-sequence star, a perfectly balanced sphere of incredibly hot plasma and roaring nuclear fusion. Every single second, deep within its crushing core, it fuses hundreds of millions of tons of hydrogen into helium. This violent reaction creates the boundless energy that radiates outward, warming the Earth and illuminating the dark interstellar space. When we look at the Earth from space, we see a vibrant blue marble, teeming with life, completely dependent on the steady, golden light of our local star. But this stability is an illusion. In the grand, unforgiving timeline of the cosmos, nothing lasts forever. Our Sun is slowly, inevitably, running out of fuel. Fast forward roughly 5 billion years into the future. The hydrogen core that has sustained our Sun for 10 billion years is finally exhausted. The delicate balance between the crushing inward pull of gravity and the outward explosive pressure of nuclear fusion is broken. Gravity, the ultimate and patient victor of the universe, takes control. The core of the Sun collapses under its own immense weight, heating up to unimaginable temperatures. This sudden, violent compression ignites the remaining shell of hydrogen surrounding the core. This is the beginning of the end. The dramatic shift in internal physics forces the Sun's outer layers to expand outward at a terrifying rate. Our once stable, life-giving star undergoes a monstrous transformation, entering the most destructive phase of stellar evolution. It becomes a red giant. As the Sun swells, its surface temperature cools slightly, shifting its light from a brilliant, blinding white to a deep, ominous crimson. But what it loses in heat, it makes up for in sheer, apocalyptic size. The solar corona expands millions of kilometers into deep space. The sky on Earth, once a calming blue, turns blood red as the massive star fills the entire horizon. The inner solar system becomes a cosmic furnace. Mercury, the closest planet, is the first to fall. It is engulfed by the expanding plasma, its rocky crust melting and vaporizing in a matter of days. Venus, with its thick, toxic atmosphere, is next. The searing heat of the red giant completely strips away the clouds of Venus, turning the entire planet into a molten wasteland before it, too, is swallowed by the expanding star. And then, the red giant reaches Earth. Long before the physical surface of the Sun touches our world, the apocalypse begins. The terrifying increase in solar radiation causes the global temperature to skyrocket. The ice caps melt instantly. The rivers dry up. The oceans, which once harbored all life on this planet, begin to boil. Billions of tons of water vapor are blasted into the atmosphere, creating a runaway greenhouse effect that turns Earth into a suffocating pressure cooker. Soon after, the immense solar wind physically strips the atmosphere away, blowing the oxygen and nitrogen out into the cold void of the cosmos. When you look at the Earth from space in this dark future, there is no blue marble. There is only a scorched, blackened rock, glowing with rivers of liquid magma. The mountains melt into glass. The tectonic plates shatter under the intense gravitational pull and thermal stress. Finally, the outer atmosphere of the red giant star engulfs the Earth completely. The planet that birthed humanity, the only known home for life in the entire universe, is incinerated and dissolved into the fiery plasma of its own dying sun. The solar system as we know it is completely erased. The sun, now a bloated red giant, dominates the local space, a bloated corpse of a once vibrant star. But this massive expansion is a final, desperate gasp for life. The red giant phase is highly unstable. Eventually, the sun will violently eject its outer layers into the deep space, creating a beautiful, glowing planetary nebula, and leaving behind only its dead, glowing core, a white dwarf. Our world is gone. But in the grand scale of the universe, the death of a single star and its planets is completely insignificant. The destruction of Earth is merely the opening act. The true nightmare of the cosmos is just beginning, and a much larger, incredibly violent event is already rushing toward us from the dark void. While the death of our sun will erase the Earth from space, a much grander, infinitely more violent event is already looming on the cosmic horizon. When you look up at the night sky, far beyond the familiar stars of our own neighborhood, there is a faint, fuzzy smudge of light in the constellation of Andromeda. That smudge is the Andromeda Galaxy. It is a massive spiral galaxy, containing roughly 1 trillion stars, and it is currently hurtling toward the Milky Way at a staggering speed of 400,000 kilometers per hour. This is not a theoretical possibility, it is a mathematical certainty dictated by the inescapable pull of gravity. For billions of years, the Milky Way and the Andromeda Galaxy have been locked in a fatal cosmic embrace, drawn together across the deep space. Right now, the distance between us seems vast, at 2.5 million light-years. But in the grand timeline of the universe, the distance is rapidly vanishing. Fast forward about 4 billion years. The night sky of Earth, or whatever dead rock remains of it, will be completely transformed. The Andromeda Galaxy will no longer be a faint smudge. It will be a terrifying, magnificent spectacle, its brilliant core and sweeping spiral arms dominating the entire sky, glowing with the light of 1 trillion alien suns. It will look like a colossal, terrifying predator descending upon our home. And then, the inevitable happens. The galaxy merger begins. However, a galactic collision is not like a car crash. The distance between individual stars is so unimaginably immense that the chance of 2 stars physically colliding is almost zero. Instead of a fiery physical impact, it is a slow, agonizing gravitational dance. As the 2 massive galaxies pass through each other, their immense gravitational fields tear their spiral arms apart. Millions of stars are violently ripped from their orbits and violently thrown out into the dark, intergalactic void. But while the stars themselves do not collide, the interstellar medium, the vast clouds of gas and dust that drift between the stars, crashes together with unimaginable force. This violent compression triggers a massive wave of star formation. The dying Milky Way is suddenly transformed into a brilliant starburst galaxy. The collision forces the dormant gas to ignite, creating millions of massive, short-lived blue giant stars that burn fiercely and die quickly in spectacular supernova explosions. The night sky will be ablaze with the light of these newborn stars and the colorful, expanding shockwaves of their immediate deaths. Deep within the heart of this chaos, a much darker merger is taking place. Both the Milky Way and the Andromeda Galaxy harbor a supermassive black hole at their respective galactic centers. As the galaxies merge, these two unimaginable monsters, each weighing millions of times the mass of our Sun, sink toward the new center of mass. They begin a terrifying, spiraling death dance, orbiting each other closer and closer. As they spiral inward, they tear apart any star unlucky enough to be caught in their gravity, consuming massive amounts of stellar material and creating a blindingly bright accretion disk space that outshines the rest of the combined galaxy. Finally, after millions of years of spiraling, the two black holes collide. The impact is so unimaginably violent that it shakes the very fabric of reality, sending massive ripples of gravity, known as gravitational waves, echoing out into the cosmos. When the chaos finally settles, billions of years from now, the beautiful, distinct spiral arms of both galaxies will be completely gone. What remains will be a single, massive, featureless elliptical galaxy. Astronomers have already named this future giant Milkomeda. It will be an ancient, red, and dying city of stars, containing the blended remnants of two once great galaxies, forever locked together in the dark deep space. The creation of Milkomeda marks a profound turning point in the history of our local universe. It is the beginning of the end for the age of starlight. Currently, we live in what astrophysicists call the stelliferous era. This is the era of shining stars, a vibrant, energetic time when the universe is filled with light, heat, and the constant birth of new solar systems. But this era is surprisingly short-lived. The fuel required to sustain this magnificent cosmic machinery is strictly finite. To create a star, the universe relies on a stellar nursery. These are massive, incredibly cold, and dense clouds of molecular hydrogen gas and cosmic dust, often seen glowing as a beautiful nebula. But star formation is an incredibly inefficient process. When a new star ignites, its powerful stellar wind blows the surrounding gas away, preventing further star formation in that immediate area. Furthermore, as galaxies age and merge, much of their free hydrogen gas is either consumed by black holes, blown out into intergalactic space by supernova explosions, or simply locked away forever in the dense, dead cores of white dwarf stars. As we move trillions of years into the future, the cosmos begins to fundamentally change. The grand, sweeping spiral galaxies that define our current era gradually lose their structure and their brilliant blue light. The raw materials required to forge new stars simply run out. The great factories of the universe slowly grind to a halt. When we look at a star-forming region in this distant future, we will not see the glowing pillars of gas or the bright blue sparks of young stars. We will only see cold, dead, empty space. The most massive stars, the brilliant blue giants and supergiant stars, are the first to go. They burn through their nuclear fuel in a matter of a few million years, exploding violently and leaving the cosmic stage almost as soon as they arrive. The Sun-like stars last longer, surviving for about 10 billion years before shedding their outer layers to form a planetary nebula and slowly fading away as a cooling white dwarf. Eventually, the only stars left burning in the entire universe will be the red dwarf stars. These are the smallest, dimmest, and coolest of all main sequence stars. Because they are so small, their internal nuclear fusion is incredibly slow and highly efficient. A single red dwarf can continue to burn steadily for trillions of years. They are the ultimate cosmic survivors. As the universe ages, its color palette shifts from the brilliant white and blue of the early cosmos to a dim, ominous, and slowly fading red. Trillions of years from now, long after the Earth and our Sun have been destroyed, long after Milkomeda has settled into a quiet, dead elliptical galaxy, the night sky will be almost completely black. The only points of light will be a few scattered, dim red dwarf stars, fighting a losing battle against the encroaching darkness. And even they cannot burn forever. One by one, as their hydrogen fuel finally runs dry, these last, stubborn embers of the universe will quietly flicker and die out. The last red dwarf will transition into a theoretical object known as a blue dwarf, briefly flashing slightly hotter before collapsing into a dead, cold white dwarf. When that final, lonely star extinguishes its flame, the universe will cross a terrifying threshold. The stelliferous era, the age of starlight that brought warmth, energy, and the possibility of life to the cosmos, will officially come to an end. The universe will plunge into an era of eternal, unbroken darkness, entering a terrifying new phase of its existence where the only dominant forces left are gravity, dead matter, and the insatiable hunger of black holes. Trillions of years after the dramatic death of our Sun, the cosmos is a fundamentally different place. The grand, sweeping structures of the spiral galaxy are nothing but a distant memory, erased by the relentless march of time and entropy. The universe has entered a period of extreme scarcity. The majestic blue giant stars and the blindingly bright starburst galaxy formations have all burned through their nuclear fuel and violently exploded. The star-forming region clouds of gas and dust have been entirely depleted. There is no new material left to forge new suns. The universe is running on empty. Yet, in this incredibly ancient, aging universe, there is one last refuge for light and warmth, the red dwarf. A red dwarf is the ultimate survivalist of the cosmos. Because they are so small, often only a fraction of the mass of our Sun, their internal crushing pressure is relatively low. This means their nuclear fusion processes operate at an incredibly slow, highly efficient rate. While a massive star might burn out in a few million years, and a Sun-like star in 10 billion years, a single red dwarf can continue to steadily fuse hydrogen into helium for trillions of years. They are the marathon runners of stellar evolution. As the universe ages and darkens, these dim, crimson embers become the most valuable real estate in the deep space. If any incredibly advanced civilizations have managed to survive the violent galaxy merger of Milkomeda and the end of the stelliferous era, they would have no choice but to migrate. They would abandon the dying, resource-depleted regions of the cosmos and cluster their generation ship fleets around these final, fading hearths. A red dwarf would become a cosmic oasis in an ever-expanding desert of freezing, absolute zero darkness. Entire empires, spanning trillions of citizens, might huddle desperately around a single, dying ember of a red dwarf, harvesting every last photon of its dim, red light to stave off the freezing death of the universe. But entropy is a fundamental law of physics, and it cannot be defeated. Not even a red dwarf can burn forever. Eventually, as the clock ticks deeper into the trillions of years, the core of the red dwarf will finally run out of hydrogen fuel. Unlike our Sun, a red dwarf lacks the mass to expand into a massive red giant. It will not shed a beautiful planetary nebula. Instead, the physics of its death are quiet and desperate. As the fusion slows, the star's gravity pulls its matter tighter together. The extreme compression causes the star's surface temperature to momentarily spike, shifting its color from a deep red to a searing, brilliant blue. For a brief cosmic moment, the dying star shines with a sudden, intense fury, radiating brilliant light out into the cosmos. But this is merely the final, dying gasp of a starving engine. The blue dwarf phase burns through its remaining, fused material in a fraction of a second on the cosmic timescale. The fusion stops entirely. The star collapses inward until the fundamental laws of quantum mechanics halt the crush. It becomes a white dwarf. A dense, dead core of degenerate matter, slowly radiating its residual heat into the frozen void. Imagine the moment the very last red dwarf in the entire observable universe goes through this process. Trillions of years of cosmic history, trillions of years of starlight, all culminating in one final, lonely flicker of blue light in an endless ocean of black. When that last red dwarf finally cools and fades into a white dwarf, the universe crosses a terrifying, irreversible threshold. The lights go out. The age of starlight, which defined the cosmos since the dawn of the first stars, comes to a permanent, absolute end. The universe plunges into a profound, suffocating darkness that will never, ever be broken by the birth of a new star. With the death of the final red dwarf, the universe officially enters the degenerate era. This is an age defined by extreme cold, absolute darkness, and the decaying corpses of the stellar era. The cosmos is no longer illuminated by the brilliant, life-giving light of nuclear fusion. The night sky is completely black. If you were to look out into the deep space during the degenerate era, you would see absolutely nothing with the naked eye. The universe has become a haunted, silent graveyard on an unimaginable scale. However, the universe is not entirely empty. It is populated by the bizarre, incredibly dense remnants of dead stars, known as degenerate matter. The most common residents of this dark era are the white dwarf stars. These are the dead, exposed cores of sun-like stars and former red dwarfs. A white dwarf is a bizarre object. It packs the mass of an entire sun into a sphere roughly the size of the Earth. The matter inside a white dwarf is compressed so tightly that individual atoms no longer exist. It is a solid crystal lattice of carbon and oxygen, held up only by the strange quantum mechanical force known as electron degeneracy pressure. At the beginning of the degenerate era, these white dwarfs still glow faintly with residual, trapped heat, radiating dim infrared radiation into the void. But with no internal fusion to sustain them, they are locked in a one-way process of cooling. Over hundreds of trillions of years, a white dwarf slowly radiates its heat away, cooling down until its temperature matches the freezing background of the cosmos. When a white dwarf finally loses all its heat, it becomes a theoretical object known as a black dwarf. A frozen, crystalline sphere of dead carbon, floating invisibly in the absolute dark of the interstellar medium. Floating alongside these freezing white dwarfs are the brown dwarf remnants. A brown dwarf is an object that was too massive to be a planet, but not quite massive enough to ignite sustained nuclear fusion in its core. They are the cosmic failures, the stars that never quite turned on. In the degenerate era, these brown dwarfs wander aimlessly through the deep space, completely dark and frozen solid, interacting with the universe only through their weak gravitational pull. But there are even darker, more terrifying monsters lurking in the blackness of the degenerate era. the violent supernova explosion of massive stars from the previous age left behind neutron star remnants. A neutron star is the ultimate expression of crushing gravity short of a black hole. It is an entire stellar core crushed into a sphere no larger than a small city. The gravity on the surface of a neutron star is hundreds of billions of times stronger than on Earth. The matter inside is squeezed so violently that protons and electrons are forced to merge, creating a solid, frictionless sphere of pure neutrons. Some of these neutron stars, known as a magnetar, possess magnetic fields so unimaginably powerful that passing too close would instantly rip the iron out of your blood and tear your atomic structure apart. And then, there are the undisputed kings of the dark universe, the black hole entities. Both the stellar mass black holes born from dying stars and the supermassive black hole monsters that once anchored the centers of vibrant galaxies now drift silently through the dead cosmos. In the degenerate era, black holes are the only objects that continue to actively shape their environment. They wander through the dark, their immense gravity occasionally sweeping up a frozen planet, a dead brown dwarf, or a wandering white dwarf. When a black hole consumes a dead star in the degenerate era, it creates a brief, violent flash of extreme energy. The dead star is torn apart by tidal forces, a process known as spaghettification, and its matter forms a swirling, superheated accretion disk around the event horizon. For a brief moment, a brilliant, terrifying light pierces the darkness of the cosmos, screaming in X-rays and gamma radiation, before the matter crosses the event horizon and is lost forever. These rare, violent collisions are the only events that break the absolute silence of the degenerate era. Two neutron stars might spiral toward each other over billions of years, finally merging in a blinding kilonova explosion, sending massive ripples of gravitational wave energy out into the freezing void. Or two white dwarfs might collide, momentarily reigniting a runaway fusion reaction that tears both dead stars apart in a massive Type Ia supernova explosion. But these flashes of light are fleeting, desperate anomalies in a universe completely dominated by the dark. The degenerate era is an unimaginably long, incredibly cold, and profoundly depressing chapter in the history of the cosmos. It is an era where nothing new is ever created, and the universe simply waits in the dark for the fundamental building blocks of matter itself to finally begin decaying. As the degenerate era deepens, the universe becomes a profoundly lonely place. The stars have all died, leaving behind only their crushed, freezing corpses. But what happened to the planets? Billions of years ago, during the vibrant stelliferous era, nearly every star in the Milky Way hosted a bustling solar system of rocky worlds and gas giants. When those stars violently expanded into red giants and subsequently collapsed into white dwarfs, their planetary systems were thrown into absolute chaos. Many planets were instantly incinerated, swallowed whole by the expanding plasma of their dying suns. Others survived the initial inferno, only to be violently ejected from their orbits by the sudden, massive loss of their star's gravitational pull. Thrown out of their native solar systems, these surviving worlds were cast adrift into the terrifying, freezing void of the dark interstellar space. They became rogue planets. In this incredibly distant future, the deep space is teeming with trillions of these wandering, dead worlds. Because there is no longer any starlight in the cosmos, these rogue planets are cloaked in absolute, pitch-black darkness. If you were standing on the surface of one of these wandering worlds, you would see no sunrise, no sunset, and no constellations. the sky would be a featureless, terrifying black void. The temperature on the surface plummets to just a fraction of a degree above absolute zero. Any planet that once possessed an atmosphere has seen it freeze solid, falling to the ground like a bizarre, planetary snowfall of solid nitrogen and oxygen. Worlds that were once entirely covered in water, resembling the deep Europa Ocean, are now frozen completely solid, turning into massive, silent spheres of ice harder than steel. Even the massive gas giants, the distant descendants of planets like Jupiter and Saturn, have cooled and contracted, their turbulent storms frozen in time, wandering blindly through the abyss. Is it possible that life still clings to existence on these dark, frozen rocks? In the very early stages of the degenerate era, some rogue planets might still retain a microscopic fraction of their internal geothermal heat, generated by the slow decay of radioactive elements deep within their cores. For a few billion years, this faint internal warmth might sustain small, pitch-black, subglacial oceans beneath miles of solid ice. In these crushing, dark depths, blind, primitive organisms might huddle around hydrothermal vents, completely unaware that the universe above them has died. But entropy is merciless. Eventually, even the radioactive elements decay entirely. The planetary cores cool and solidify. The last subglacial oceans freeze completely to the center. The rogue planets become entirely dead, sterile rocks, doomed to drift through the deep space dark void cold universe for trillions upon trillions of years. These invisible worlds cross paths with nothing, interacting only occasionally when their faint gravitational fields brush against another wandering ghost. In the absolute silence of the degenerate era, these trillions of frozen planets are the tragic, forgotten monuments of a universe that used to be full of light and life. While the vast majority of the universe during the degenerate era is characterized by cold, silent isolation, the absolute darkness is occasionally pierced by events of unimaginable, terrifying violence. Gravity, the most persistent and patient force in the cosmos, never stops working. Over periods of time that completely defy human comprehension, the dead remnants of the stellar era are slowly, inevitably drawn together. During the age of starlight, a massive percentage of stars existed in a binary star system, two stars orbiting a common center of mass. When these stars died, they left behind their crushed, degenerate cores, paired combinations of a white dwarf, a neutron star, or a black hole. These dead binary systems continue to orbit each other in the pitch-black void. However, according to the laws of general relativity, any massive objects orbiting each other will create ripples in the very fabric of space-time. These ripples are known as gravitational waves. As a binary star system emits gravitational waves, it slowly leaks orbital energy out into the deep space. This loss of energy causes the two dead stars to spiral closer and closer together. This process is agonizingly slow, taking billions or even trillions of years to unfold. But the outcome is a mathematical certainty. Eventually, the two massive corpses will collide. Imagine a binary system consisting of two dead, freezing white dwarfs. As they spiral in and finally merge, their combined mass suddenly exceeds the Chandrasekhar limit, the absolute maximum mass a white dwarf can possess before its internal structure fails completely. In a fraction of a second, the crushing gravity triggers a runaway thermonuclear fusion reaction that consumes both dead stars simultaneously. The resulting explosion is a Type Ia supernova. For a brief, glorious moment, a brilliant, blinding flash of light tears through the absolute darkness of the degenerate era, momentarily outshining the ghosts of a billion dead galaxies. But an even more terrifying collision occurs when two neutron stars merge. As these incredibly dense, city-sized atomic nuclei smash together at a significant fraction of the speed of light, the impact shatters the laws of physics. The collision triggers a kilonova explosion, a blast so energetic that it literally rips the fabric of space-time, sending massive, tsunami-like gravitational waves echoing across the dead cosmos. The intense heat and pressure of the kilonova forge the heaviest element in the universe, blasting a glowing, radioactive cloud of gold, platinum, and uranium out into the dark interstellar space. Yet, these spectacular cosmic fireworks are merely the final, dying spasms of a decaying universe. The blinding flashes of a Type Ia supernova or a kilonova last for only a few weeks or months, an infinitesimally brief spark in the endless night. And the result of these massive collisions only accelerates the ultimate death of the cosmos. When two neutron stars merge, their combined mass collapses under its own terrifying gravity, tearing a hole in space-time and forming a brand new black hole. Every flash of light in the degenerate era is simply the universe forging another dark, inescapable monster, preparing for the next, even darker epoch of cosmic history. As we push our timeline forward to the unimaginable milestone of 10 to the power of 34 years into the future, the cosmos crosses a threshold so profound that it permanently alters the fundamental nature of reality. The degenerate era has been incredibly long, but it is ultimately just a waiting room. The white dwarfs have completely frozen into black dwarfs. The neutron stars are silent. The trillions of rogue planets are drifting, frozen tombs. Up until this point, the universe has changed its shape and its temperature, but the fundamental building blocks of matter, the atoms, the protons, and the neutrons, have remained largely intact. But in this incomprehensibly distant future, physics itself begins to break down. According to grand unified theories of particle physics, the proton, the positively charged particle that forms the very heart of every atom in existence, is not immortal. Protons are incredibly stable, but over timescales that shatter the human mind, they are predicted to decay. The half-life of a proton is estimated to be roughly 10 to the power of 34 years. This means that if you wait long enough, the subatomic glue holding reality together simply dissolves. A proton will spontaneously decay into a positron and a neutral pion. These subatomic particles will immediately interact, annihilating each other in a microscopic flash of gamma radiation. What does this mean for the universe? It means that matter itself is slowly, inevitably evaporating. Imagine one of the countless, frozen rogue planets drifting in the deep space. It does not shatter. It does not explode. Instead, atom by atom, it simply begins to dissolve. A microscopic flash of gamma radiation here, another one there. Over billions of years, the solid rock and frozen ice of the planet slowly turn into a faint, glowing mist of pure energy, dissipating outward into the expanding universe. The same horrifying fate awaits the black dwarfs. The crushed, crystalline carbon cores that were once brilliant, life-giving suns slowly erode from the inside out. They lose their mass, atom by atom, steadily shrinking as their protons decay into light and vanish into the dark void. Even the incredibly dense, frictionless spheres of the neutron stars are not immune. They, too, will slowly dissolve into a faint haze of radiation. This period is the true death of the physical universe. The process of proton decay is agonizingly slow, taking incredibly vast stretches of time to completely erase a single dead star. But time is the one thing the dying universe has in absolute abundance. As the clock ticks toward 10 to the power of 40 years, the last remaining atoms in the cosmos finally fail. The last black dwarf evaporates into a whisper of photons. The last frozen planet dissolves into nothingness. When the era of proton decay finally concludes, the universe has been completely wiped clean. There are no planets. There are no moons. There is no dust, no gas, no rocks, and no atoms. The entire periodic table of elements, forged in the hearts of ancient stars and scattered by supernova explosions, has been completely erased from existence. All baryonic matter has been deleted. The only things left in the entire, unimaginably vast expanse of the cosmos are elementary particles of light, a thin soup of subatomic radiation, and the silent, terrifying gravity wells of the supermassive black hole empires that now inherit the ruined universe. We have now crossed a temporal threshold that shatters human comprehension. It is 10 to the power of 40 years into the future. All baryonic matter, the protons and neutrons that once formed the magnificent spiral galaxy structures, the vibrant nebula clouds, and the solid rock of every planet, has entirely dissolved into a thin, freezing mist of subatomic particles and photons. The periodic table is completely erased. The universe has been brutally swept clean of its physical history. But the cosmos is not entirely empty. It has simply been handed over to its final, undisputed rulers. Welcome to the black hole era. In this unimaginably dark epoch, the only macroscopic structures left in the entire expanding universe are black holes. During the glorious, long-forgotten age of starlight, these gravitational monsters were merely hiding in the centers of galaxies or lurking in the shadows of dead star systems. Now, they are the only things that remain. There are the stellar mass black holes, the ancient ghosts of massive blue supergiant stars that collapsed billions of years ago. And then there are the true leviathans, the supermassive black hole entities, the gargantuan gravitational anchors that once held entire galaxies together, some possessing the mass of tens of billions of suns. Because there is absolutely no gas, no dust, and no stray planetary bodies left to consume, these black holes are completely starved. They no longer possess a glowing accretion disk. There is no brilliant corona of X-ray radiation to announce their presence. Without a black hole accretion disk glowing to illuminate their boundaries, they are perfectly, flawlessly invisible. They are nothing more than terrifying, silent spheres of warped space-time, drifting blindly through the deep space dark void cold universe. The distances between these remaining black holes are staggering, expanded to incomprehensible lengths by the relentless push of dark energy cosmos expansion space. Yet, gravity is infinite in its reach. Over periods of time that require writing a 1 followed by dozens of zeros to even express mathematically, these invisible titans occasionally find each other in the pitch-black abyss. When two supermassive black holes finally enter a mutual orbit, they begin a silent, deadly dance that lasts for trillions of years. They slowly spiral inward, bleeding their orbital momentum into the void as gravitational waves. When their event horizons finally touch, the resulting galaxy merger of pure gravity is an event of absolute, unspeakable violence. The collision shakes the very fabric of reality, sending tsunamis of gravitational energy echoing across the empty cosmos. But to a hypothetical observer, this apocalypse would be completely silent and completely invisible. There is no flash of light. There is no explosion. There is only the silent merging of two shadows into a single, deeper darkness, sinking further into the cosmic abyss. In the black hole era, the universe is a blind, freezing ocean where invisible leviathans silently hunt each other in the absolute dark. For decades, human physicists believed that a black hole was eternal. Once a black hole formed, it was thought to be a permanent, indestructible scar on the fabric of space-time. A cosmic roach motel where matter and energy check in, but nothing ever checks out. Even light itself, traveling at the absolute speed of light, cannot escape the crushing grip of the event horizon. But in the late 20th century, physicist Stephen Hawking revolutionized our understanding of these gravitational monsters, revealing a stunning and terrifying truth: black holes are not immortal. They leak. And eventually, they die. To understand how a black hole dies, we must look not at gravity, but at the bizarre, counterintuitive laws of quantum mechanics. Even in the deepest, emptiest vacuum of space, the universe is never truly empty. According to quantum field theory, the void is constantly boiling with vacuum energy quantum space void cosmos. Microscopic pairs of virtual particles and antiparticles are constantly popping into existence, borrowing energy from the vacuum, and then instantly annihilating each other to repay the debt. This quantum fluctuation happens everywhere, all the time, completely unnoticed. But what happens when this quantum boiling occurs right on the razor-thin edge of a black hole's event horizon? The terrifying gravity of the singularity distorts the rules. When a pair of virtual particles pops into existence directly on the boundary, the intense tidal forces can violently pull them apart before they have the chance to annihilate. One particle is sucked across the event horizon and falls into the black hole forever. The other particle, violently separated from its partner, is boosted by the extreme gravitational energy and escapes out into the deep space. To the rest of the universe, it looks as though the black hole has just emitted a particle. This phenomenon is known as Hawking radiation. But the laws of thermodynamics demand a price. Energy cannot be created from nothing. The particle that fell into the black hole has negative energy, meaning it effectively subtracts a microscopic fraction of mass from the black hole itself. Over time, as it emits Hawking radiation, the black hole slowly, agonizingly loses its mass. It evaporates. The timeline for this evaporation is the most mind-crushing concept in all of astrophysics. A black hole with the mass of our Sun would take roughly 10 to the power of 67 years to completely evaporate. That is a 1 followed by 67 zeros. But the supermassive black hole monsters, the ones that weigh billions of times more than our Sun, take infinitely longer. For the largest known black holes to evaporate, it will take 1 googol years. That is 10 to the power of 100 years. A number so vastly, incomprehensibly huge that if you were to write a 0 on every single atom in the entire observable universe, you would still run out of atoms before you could write the number out completely. Yet, in the black hole era, time is the only resource that exists in infinite supply. The clock ticks away the eons. The universe waits. Slowly, invisibly, the great monsters of the cosmos begin to shrink. As a black hole loses mass, its gravitational grip weakens, and its temperature paradoxically increases. The smaller it gets, the faster it evaporates, and the hotter it becomes. The black holes are bleeding out into the dark, shedding their stolen mass particle by particle, photon by photon, slowly fading away into the freezing background of the dying cosmos. As we approach the unimaginable milestone of 1 Googol years into the future, the cosmos is preparing for its final, definitive act. The black hole era has been an age of agonizingly slow decay. For octillions of years, the universe has been completely devoid of any macroscopic structures, save for the shrinking, evaporating spheres of absolute darkness. But the process of Hawking evaporation is not a quiet, gentle fade into nothingness. It ends in sudden, spectacular violence. As a black hole shrinks down to its final fractions of a percent, the mathematics of Hawking radiation accelerate exponentially. The black hole becomes incredibly hot, radiating energy faster and faster. When the mass of the black hole reaches roughly the size of a large mountain on Earth, it is no longer the cold, silent killer it once was. It is a blindingly hot, furiously unstable sphere of quantum fury. In its final seconds, the remaining mass of the black hole is converted entirely into pure energy in a fraction of a millisecond. The resulting detonation is equivalent to billions of nuclear weapons detonating simultaneously. The dying black hole explodes in a blinding, catastrophic flash of high-energy gamma rays and particles. It is a miniature supernova explosion, a brilliant spark of light and heat tearing through the absolute darkness. For a brief, glorious moment, the cosmos is illuminated once again. But this light has no eyes to see it. There are no planets left to warm. There are no star-forming regions left to ignite. The expanding shell of gamma radiation simply pushes outward into the infinite, featureless void, slowly stretching and cooling as it travels across the expanding universe. Imagine being there to witness the very last supermassive black hole in the entire cosmos reaching this critical point. It is the final anchor of gravity, the last remaining ghost of the galaxy cluster that once held trillions of stars. As it reaches its final microscopic size, it detonates in a solitary, blinding flash of pure white light. That flash is the grand finale. It is the closing curtain of physics. It is the very last macroscopic event that will ever occur in the history of existence. As the light from that final explosion fades, traveling outward at the speed of light, its photons are stretched by the relentless expansion of space. Their wavelengths become longer, their energy drops, and their light shifts from visible to infrared to microwaves, and finally into the faint, undetectable static of radio waves. When the last photon from that final explosion cools and fades into the absolute zero background of the void, the universe crosses its ultimate threshold. The last light in the universe has gone out, and it will never, ever be rekindled. The cosmos is finally, truly, and eternally dead. The brilliant, blinding flash of the very last supermassive black hole evaporating was the final punctuation mark in the long, chaotic story of macroscopic physics. When that final burst of gamma radiation stretched, cooled, and ultimately faded into the invisible background static of the void, the cosmos officially crossed its final threshold. It entered the dark era. This is the ultimate, terminal stage of cosmic evolution. There are no more transitions. There are no more eras to come. This is the permanent, unchanging state of reality. If you could somehow stand in the center of the universe during the Dark Era, what would you see? The answer is absolutely nothing. You would be engulfed in a deep space dark void cold universe that defies all human comprehension. There are no stars, no planets, no black holes, and no atoms. The entire inventory of the cosmos has been reduced to a microscopic, incredibly dilute soup of elementary particles. There are only wandering photons of light that have lost almost all their energy, ghostly neutrinos that interact with nothing, and perhaps a few stray electrons and positrons separated by unimaginable, terrifying distances. But the universe is not at rest. The most insidious and powerful force in the cosmos, dark energy, remains completely undefeated. Long after the stars have died and the black holes have evaporated, dark energy continues its relentless work. It continues to drive the expanding universe at an exponentially accelerating rate. The very fabric of space-time is being stretched faster and faster. Because of this dark energy cosmos expansion space, the few remaining subatomic particles are being pushed away from each other at speeds exceeding the speed of light. The physical isolation of this era is absolute. In the modern universe, space is relatively crowded. But in the Dark Era, the distance between two single electrons might be greater than the entire width of our current observable universe. If a photon is traveling through the abyss, it could fly in a straight line for googolls of years without ever encountering another particle, a magnetic field, or an obstacle of any kind. Every single particle in the cosmos is locked in a state of permanent, inescapable solitary confinement, drifting alone in a rapidly expanding ocean of nothingness. This process leads us to the most depressing and inescapable conclusion in all of thermodynamics, the heat death. Despite its dramatic name, the heat death universe cold dark empty space is not a fiery apocalypse. It is exactly the opposite. It is the ultimate freeze. It is the final victory of entropy. To understand the heat death, we must understand how the universe does work. Everything that has ever happened, a star burning, a planet forming, a human heart beating, or a black hole feeding, requires a difference in temperature. Energy flows from a hot place to a cold place, and in that flow, events happen. Life happens. Complexity happens. But entropy is the universal law that states that over time, all energy tends to spread out evenly. Differences in temperature are slowly erased. The hot coffee cools down to room temperature. The burning star eventually cools into a dead cinder. In the Dark Era, after an unimaginable stretch of time, the expanding universe forces all the remaining energy to spread out completely evenly across the infinite void. The temperature of the cosmos continues to drop, asymptotically approaching absolute zero. It will reach a fraction of a billionth of a degree above absolute zero, and it will be exactly the same temperature everywhere. When the entire universe reaches a state of perfect thermal equilibrium, the machine stops. Without a difference in temperature, energy can no longer flow. Without the flow of energy, no physical work can ever be done again. The engine of reality simply seizes up. No particle can interact with another particle. No complex structures can ever form. Information can no longer be processed or transferred. The universe has reached its state of maximum entropy. It is a perfect, flawless, and eternally dead equilibrium. In this frozen, static eternity, we must confront a deeply philosophical question: does time still exist? We measure time by observing change. We measure a year by the orbit of a planet. We measure a second by the ticking of a clock or the vibration of a quartz crystal. We measure cosmic epochs by the birth and death of stars. Time is fundamentally linked to the sequence of events. But in the heat-death, there are no events. Nothing changes. Nothing moves. Nothing happens. 1 year looks exactly the same as 1 trillion years, which looks exactly the same as 1 Googleplex years. Because the universe has reached a state of maximum entropy, the arrow of time has completely flattened out. Without any physical changes to mark its passage, time itself loses all meaning. The cosmos is not merely dead, it has slipped outside the boundaries of time. It exists in an eternal, unchanging, and absolute pause, a silent monument to a universe that once burned so brightly in the dark. We have painted a picture of the heat-death, a slow, agonizing fade into a frozen eternity where the universe ends not with a bang, but with a whimper. This is the widely accepted fate of the cosmos based on our current understanding of thermodynamics. However, the universe is under no obligation to be peaceful. There is an alternative, far more violent, and deeply terrifying scenario for the end of everything. It is a cosmological nightmare known as the Big Rip. To understand the Big Rip universe expansion tearing space, we must look at the most mysterious force in the cosmos, dark energy. We know that dark energy cosmos expansion space is accelerating the growth of the universe. But what if the nature of this dark energy is not constant? What if, as the universe expands, the actual density and power of dark energy continue to increase? If this hypothetical form of dark energy, sometimes called phantom energy, exists, the expansion of the universe will eventually reach a critical, catastrophic velocity. It will not just push distant galaxies away, it will become strong enough to overcome the fundamental forces of nature that hold matter together. If the Big Rip scenario is our true destiny, the end of the universe will be a highly structured, violently orchestrated dismantling of reality. It will happen in distinct, horrifying stages. Billions of years before the end, the phantom energy becomes stronger than the gravitational pull holding the galaxy-clustered deep space many together. The great superclusters, the largest structures in the universe, are violently torn apart. Galaxies that have been gravitationally bound for tens of billions of years are suddenly pulled away from each other at speeds exceeding the speed of light. The night sky is stripped of all distant light. Millions of years before the end, the dark energy becomes so incredibly powerful that it overcomes the supermassive black hole at the galactic center. The galaxy itself is shredded. The spiral arms are ripped away, and individual stars are scattered violently into the dark intergalactic void. Our Milky Way, or the dead remnant of Milkomeda, ceases to exist as a cohesive structure. Months before the end, the dark energy penetrates the solar system planet's orbit space. The gravitational bond between the dead central star and its orbiting planets is completely overwhelmed. The planets are violently ripped from their orbits and flung out into the rapidly expanding abyss. In the final hours, the dark energy overwhelms the electromagnetic force holding solid matter together. The rogue planets and dead stars literally explode, their rocky crusts and crystalline cores shattering into dust. In the final fraction of a second, the phantom energy becomes stronger than the strong nuclear force. The very atoms themselves are torn apart. The protons and neutrons are ripped to shreds. The physical fabric of space-time itself is stretched to infinity and violently torn open. If the Big Rip occurs, the universe does not slowly freeze to death, it is violently, actively murdered by the very space it occupies, leaving behind absolutely nothing but disconnected, isolated subatomic particles in a shattered void. Whether the universe ends in the slow, freezing silence of the heat death or the violent tearing of the Big Rip, we are faced with an ultimate, agonizing question: is this truly the end? When the last black hole has evaporated, when the last atom has decayed, and when the cosmos has entered an eternal state of maximum entropy, is there any hope for a new beginning? If we look at the universe as a single, isolated system, the answer is a bleak and terrifying no. But modern theoretical physics suggests that our universe might not be the only one. We may be living in a multiverse universe parallel cosmos. According to the theory of eternal inflation, the rapid expansion that birthed our universe, the inflationary epoch, never actually stopped. It is continuously happening outside the boundaries of our observable universe. In this theory, the grand cosmos is like an infinitely boiling ocean of energy. Occasionally, a microscopic bubble forms in this boiling ocean, stops inflating, and cools down, crystallizing into a stable universe with its own unique laws of physics. Our universe, with its galaxies, stars, and planets, is just one single, microscopic bubble in a frothing, infinite sea of parallel realities. While our specific bubble is expanding, cooling, and dying, countless other bubbles are being born. In the multiverse, the Big Bang universe explosion cosmos creation is not a singular, unique event that happened only once. It is a continuous, eternal process. Out there, beyond the terrifying emptiness of our dying cosmos, there are brand new universes where the first stars are just beginning to ignite. There are universes where the laws of physics are so wildly different that gravity pushes instead of pulls, and light travels at a completely different speed. Even if we reject the multiverse theory and focus only on our own dead universe, quantum mechanics offers one final, mathematically bizarre glimmer of hope. In the frozen, infinite eternity of the dark era, time has no meaning. And when you have an infinite amount of time, the laws of probability begin to break down. According to quantum fluctuation Big Bang early universe principles, even in a perfect vacuum at absolute zero, energy can spontaneously borrow itself from nothingness for an infinitesimally brief moment. Usually, these quantum fluctuations are microscopic and instantly vanish. But if you wait an infinite amount of time, absolutely any event that has a non-zero probability of happening will eventually happen. In the endless, dead void, a random, massive quantum fluctuation could theoretically occur, spontaneously generating a massive concentration of energy. This incredibly rare, almost mathematically impossible event would trigger a brand new Big Bang. Out of the cold ashes of the dead universe, a completely new cosmos would violently explode into existence, filled with new hydrogen, new physics, and the potential for a completely new timeline of stars and galaxies. The death of our universe might simply be the long, silent gestation period for the next one. We have traveled from the violent, fiery death of our sun to the collision of galaxies, from the fading of the last red dwarf to the agonizing decay of matter itself. We have watched the supermassive black holes evaporate into the dark, and we have witnessed the universe stretch itself into a frozen, timeless eternity. This is the ultimate, inescapable destiny of all things. When we look up at the vibrant, glowing tapestry of the night sky today, we are incredibly privileged. We are living in a tiny, fleeting window of cosmic time where light, warmth, and complexity are possible. The universe is currently a loud, violent, and beautiful machine. But this machine is winding down. The grand story of the cosmos is a story of a brilliant spark fading back into the dark. For those who fear the dark forest, who worry about the unseen hunters and the violent predators lurking in the interstellar space, the end of the universe offers a strange, haunting comfort. The great filter will eventually consume everything. The hunters and the hunted, the advanced artificial intelligences and the primitive biological worlds, will all face the exact same ultimate fate. The playing field will be perfectly, flawlessly leveled by the relentless march of entropy. In the very end, there is no pain. There is no war, no hunger, and no fear. The cosmic graveyard will be swept entirely clean. The universe will return to the state from which it was born, a state of absolute, perfect equilibrium. As the final photons of light stretch and fade away, and the temperature of the void settles into the permanent, unyielding grip of absolute zero, the cosmos will finally find its ultimate peace. It will breathe its last, microscopic sigh, and then, for the rest of eternity, there will be nothing left to say. There will be no one left to listen. The deep space dark void cold universe will claim its final victory. Thank you for joining us on this journey to the end of time. Until we meet again in the dark, this is Silence of Space. We tell the universe,